We're going to solve the integral of sine squared x times cosine of x dx. Now, using our current integral knowledge, we aren't able to solve this integral. But by introducing U-substitution, we will be able to set one of the components of this integral. We'll set it to this arbitrary variable u, and then let me not go too much in depth yet because if I explained it here, it's gonna completely fly over your head. But by doing it with you and explaining my steps, hopefully, it'll make more sense. But before I even begin my u-sub, I want to rewrite this. I want to rewrite this as the integral of sine of x squared times cosine of x dx. Okay, now these two integrals are the same thing. This sine squared x and sine of x, all of that squared, same thing. So now let me introduce u-substitution. So I want to do as I'm not going to call myself a mathematician, as as someone doing calculus right now. Can't I just say that, okay, I want to take the sine of x and I want to call it this arbitrary variable u. Can I do that? Yeah, I can, because sine of x, I set that equal to u. I put it off on the side. I'm saying, okay, I want to use this variable u and I'm calling it sine of x. Nothing wrong with that. Now, here's where it gets interesting. I want to take the derivative of du of, I want to take the derivative of u. So this is going to be the change in u with respect to the change of x. This is Leibniz notation of the derivative. Oh, wait, no, I wrote du twice. That um, du dx. Now, what's the derivative of sine of x? Okay, well, cosine of x, that's uh, doesn't really need a proof. That's just, I mean, you have memorized that. Okay, now I'm gonna do my algebra in blue. Du equals cosine of x dx. I just multiplied by dx on both sides, and therefore, let's go back now that we just showed that little algebra step, because um, when doing something challenging at first, let's show you guys something familiar. Let's just show you some basic algebra, because while you're first learning this, it's kind of not, I would say, like, kind of hard that we just jumped from this to this. You just want to take it by slowly so you can just really conceptualize this. We're not doing anything. We're just manipulating the Leibniz notation derivative. I want to make a video on this. It's quite interesting. But we just manipulated. We multiplied by dx on both sides, and then we got and then we just divided by dx. So no, we divided by cosine x, sorry. So that, which gave us that dx equals d over cosine of x. So I'm gonna do this in gray. This is our box of u-sub. This is our box. This is our box of u-substitution. We just said, I want to set sine of x in this integral as u. I'll take its derivative, which is cosine of x. Okay, that's all good. And then I just solved for d of x. That's all good. Now, you might see where this is going, or you might not. But by the end of this, we all will get a basic understanding of u-substitution. I won't say we would have mastered it yet, because that's quite ambitious in my teaching skills. So, times, okay, u, because sine of x, we said sine of x equals u. I just want to substitute in as u. Okay, that's good. I don't really see the purpose of it, though. Why are we substituting sine of x as u? Well, cosine of x, okay, that stays the same. We didn't set any variables for cosine of x. Now, this d of x, we said that d of x equals du over cosine of x. Du over cosine of x. Now this is where u-sub really shines. Cosine of x and cosine of x. These two cancel. Okay? These two cancel. What are we left with? We're left with the integral of u squared times du. The integral of u squared times du. Okay, now this integral just got way easier to solve. This is just reverse power rule. So the answer here would be 1/3 u cubed, and then of course we can check our work by taking the derivative of this. Okay, 3 times 1/3, 1, u, and then 3 minus 1, 2, so u squared, okay, and then our constant c, because the derivative of a constant would just be 0, So this integral that we would have no idea how to solve, because how would I solve it? By doing some basic manipulation that is all valid. All this is just valid manipulation. I just want to set it as some variable. I'll take its derivative and I'm gonna find for dx. Now I want to substitute this dx and this sine of x for u and du over cosine of x. By doing so, the cosine of x's cancel, and I'm left with the integral of u squared times du. And now I have 1/3 u cubed plus c. And that isn't our final answer because we're just one step away. We're gonna put the sine of x back into the equation because I just want to plug it back in. So sine of x cubed plus c. And hopefully that gave you some insight into the usefulness of U-substitution, that we had this integral that we could not solve because um, like I know the integral of cosine of x is what? Sine of x, but when I multiply by sine squared x, how am I really supposed to get it? And then so that's why we would do U-substitution. And then if you're wondering, oh, how do I know when to properly choose my u's? Um, it's really with practice you're gonna get really good at it of knowing which u's that you which parts of the equation that you should set to u, and you'll gain some insight. Like you'll see two steps ahead. You say, okay, if I choose sine of x, the derivative of sine of x is cosine of x, and then okay, when I solve for d of x, it's going to be du over cosine of x. Cosine of x's are going to cancel. Yeah, that's my proper variable. Because if I substituted it in for sine of it, if I said u was equal to cosine of x, that wouldn't have made it as easy to solve as doing it like this. And since we have time, let's just do one more integral. I I I don't want to make this too short and only do one. I don't want to make it too long though, but let's just do one more integral. Let's do this one. Let's do the integral of x plus 1 over x squared plus 2x cubed d of x. We are not able to solve this using basic integration techniques, so that's where u sub comes into play. And pause the video. Which variable should I use as u? Which part of the equation should I set as u? Assuming you've paused the video, I would do x squared plus 2x. And the reason I would do so is because when I take the derivative of this, du dx, I'm going to get 2x plus 2, which in this step, I'm going to pluck out the 2, and I'm going to get x plus 1. 2x plus 1. I just rewrote this, okay? And therefore, dx equals du over 2x plus 1. So I have all the variables I want. I have all the variables. I have my variable u, which we said, let's do blue. We said u equals x squared plus 2. So this x squared plus 2x, I want to substitute in it for u. And this d of x, I want to substitute in for du over 2x plus 1. So now let's solve. X plus 1, the integral of x plus 1 over u cubed, and then times du over 2x plus 1. Okay, now what can I cancel? You see these two x plus 1s? These two x plus 1s cancel. Therefore, this leaves me with the integral of 1 over u cubed times 1/2 times du. And because du over 2 is the same as 1/2 times du. Let's simplify this again. The integral of u to the negative 3 times 1/2 du. I should have done this in two steps. Okay, let me pluck out the 1/2 here. The integral of u to the negative cubed du. Okay, and now let's solve for this. Okay, so this is just going to be 1/2 times by reverse power rule, this is going to be negative 1/2 u to the negative 2 plus c, which is going to equal negative 1/4 u to the negative 2 plus c. Okay, and now in green, let's plug back in our u. Therefore, this integral equals negative 1/4 of x squared plus 2x to the negative 2 plus c. And have a good day.